Just wait for everybody to get their color code schemes together. So on the unit circle, with the intersection of the axes, those are the 4 points that will be on the unit circle, part of the axes family. If we think about degrees and this first point right here, well, that would be 0 degrees, or if we went all the way around, 360 degrees. Standard position starting at the positive x-axis, you can see that that would be 90 degrees, right? Halfway around to this point would be 180 degrees. To get to the point at the bottom, you would have 270 degrees. Then in radians, well, 0 and 360 is the same as 0 and 2 pi. You know that 180 is the same as pi. 90 degrees is half of 180, so it would be half of pi. And 270 is 3 pi over 2. Since the unit circle has a radius of 1, if I went 1 to the right, does it make sense that this coordinate is 1, 0? If I went 1 up from 0, 0. So the unit circle is based on the idea that right at the center is 0, 0. This would be 0, 1. Negative 1, 0. And finally, 0, negative 1. Who wants to pick a volunteer? So if you get chosen, you're for sure not going to be the first volunteer. Okay. So what the question's going to be before you pick person, I want you to tell me what cos of 90 degrees is. Pick someone. You can just say it from there. First one's always the hardest. Cos of 90 degrees. Close. Coordinates. Notice our coordinates are cos, sine. So if I say cos of 90 degrees, I'm looking for an x-coordinate at 90 degrees. 0. Pick another volunteer. Joseph gets to pick. Sometimes that happens. What would sine of 270 degrees be? Negative 1, because sine is the y-coordinate. 270 is right here. Now we know sine of 270 degrees is negative 1. Sarah, pick another volunteer, someone different. We are now going to figure out what cos of pi is. Florian. Minus 1. Good. Now we're going to figure out sine of negative pi over 2. Sine of negative pi over 2. Pick a volunteer. Hiroki. Minus 1. Now negative pi over 2 would start here and go in this direction. Can you see that it would be coterminal with 3 pi over 2? And since we're figuring out sine, we would look at the y-coordinate. So this is where the coordinates of the unit circle, and knowing how to label them, now you can do without a calculator any angle that would end on one of the axes. So if I asked you what is cos of 3,600 degrees, 3,600 degrees ends at the same place as 360 degrees. and cos would be equal to 1. So if you type it into your calculator and your calculator's in degrees, cos 3,600 degrees, push enter, it will come out as 1. That's one of our big ideas, that all coordinates are cos comma sine. Another big idea is with tangent, and tan is sine over cos. So can you see that tan of 0 radians, and I'll just do it with the radian measures here. If I did 0 divided by 1, what would I get? 0. Tan of 0 is equal to 0. Similarly over here, if I would do tan of pi, or tan of 180 degrees, 0 divided by -1 is 0. What happens when I do tan of pi over 2? I would get 1 divided by 0. Uh-oh. That's not good, right? So what we write is undefined. It's not possible because you can't divide by 0. So tan of pi over 2 is undefined, and similarly, we would say that tan of 3 pi over 2 is undefined. That is our first family. Yes?
But now before we are coming to tan pi over half on the right side, that should be bigger figures. Because then
It does get larger and larger, but eventually it is not defined because you divide by 0. And if you type it into your calculator will tell you the same thing.
so we are going to infinity before we are coming to 1.
Pi over 4 family is our next family. Now you have a little bit of space in between your two circles. In that space in between your two circles, we're going to write special triangle for 45 degrees or pi over 4. Because if we're going to figure out sine of 45 degrees without our calculator and cos of 45 degrees without our calculator, we need a way to be able to make sense of that. And so the way to do that, since we know sine, cos, and tan for right-angled triangles, is we're going to draw a right-angled triangle. And we're going to make one of the angles 45 degrees. If we do that, what's the other angle? Also 45. What's the name of this kind of triangle? Isosceles. Isosceles triangles have two angles that are the same. They also have two sides that are the same. Now, sine, cos, and tan are ratios, and it doesn't matter how big or how small that triangle is. The ratio of the opposite over hypotenuse, or opposite over adjacent, or adjacent over hypotenuse will stay the same no matter how big or how small that triangle is. Since we know these two sides are the same, we can pick any number we want and label this triangle. For simplicity's sake, I'm going to pick 1 and 1. If you picked 37 and 37, the results will stay the same. But a squared plus b squared equals c squared with 37 isn't as easy to do as it is with 1. If I did a squared plus b squared equals c squared, 1 squared plus 1 squared is 2. Square rooting that will tell me that my hypotenuse has to be the square root of 2. Looking at this now, what is sine of 45 degrees? Opposite over hypotenuse will be 1 over root 2. If we wanted to rationalize this by multiplying top and bottom by root 2, you'd get root 2 over 2. Both of these answers would be acceptable. Throughout the year, I'm going to use the rationalized one, root 2 over 2. more often than 1 over root 2. Can you see that cos of 45 would be identical? So I'll just write root 2 over 2 to start. And tan of 45 will be equal to opposite over adjacent, 1 over 1, which would just be 1. Can you see if you use 37 and 37, you'd get 37 over 37, which would reduce to 1. If you use 37, you would get 37 root 2 over 74, which would reduce to root 2 over 2. Yes? The 1 over root 2. Then if I took 1 over root 2 and I rationalized the denominator by multiplying the top by root 2 and the bottom by root 2, I'm going to get root 2 on the top, and root 2 times root 2 is just 2. Okay. So there's our special triangle. That's going to help us label everything on here. We can start with degrees. If our reference angle is 45 degrees. If we have the same reference angle in quadrant 2, 180 minus 45 will leave us with 135 degrees. Same reference angle in quadrant 3 would be 180 plus 45, 225 degrees. Same reference angle in quadrant 4, 360 minus 45, 315 degrees. The really nice thing about radians is that you can easily tell if something belongs to the same family or has the same reference angle. Because our first angle is pi over 4. If we think of this as a certain size, and we count by that size, can you see that I have 1, 2, 3 of them to get to this one? 3 pi over 4. 4, 5 to get to this one. 5 pi over 4. 6, 7 to get to this one. So anything that has a reference angle of pi over 4, if the fraction is reduced as low as it can go and you get a pi over 4, you know that its reference angle is pi over 4, which is really powerful because you can tell that 101 pi over 4, even though it goes around the circle many, many times, will have a reference angle of pi over 4. But if I told you a large, large angle like 3,555, it might take you a while to figure out, yes, that has a reference angle of 45 degrees as well. Now our points, which are cos comma sine. Well, cos is root 2 over 2, and sine is root 2 over 2. So we know that point. When I go straight across to this point, my x-coordinate's now negative, which makes sense according to the cast rule, because cos, which is the x-coordinate, is negative in quadrant 2. And your y-coordinate would still be positive, because sine is positive, and you can see directly there that it would be positive. In quadrant 3, they would both be negative, because both sine and cos are negative in quadrant 3, and obviously that coordinate is negative in quadrant 3. Finally, in quadrant 4, cos would be positive, but sine would be negative. And we'll quickly do tan, and that's where we'll end for today. We know that tan of pi over 4 is equal to 1. In quadrant 2, tan is negative, so it'll equal negative 1. In quadrant 3, tan is positive, so it'll equal positive 1. And in quadrant 4, tan is negative, so it'll equal negative 1. So for the pi over 4 family, if you know quadrant 1, you should be able to figure out all the other quadrants.